A rocky headland reaches into the Indian Ocean along the southern tip of South Africa. Waves break against limestone cliffs pocked with sea caves. This is what archaeologists call Pinnacle Point. For most of its history, it has been nothing more than a scenic stretch of coastline near the town of Mossel Bay. For a few hundred people, roughly 200,000 years ago, it may have been the only address left for our entire species. Humanity has never struggled for territory since. We are on every continent except Antarctica. In deserts, in jungles, on ice sheets, crammed into cities of 20 million people. It is easy to assume we have always been this way. Spread out, resilient, impossible to seriously threaten as a species. The kind of species that survives by sheer numbers if nothing else. But there was a stretch of time, not that long ago in geological terms, when almost none of that was true. When the entire population of Homo sapiens on Earth may have narrowed down to a few hundred people, clinging to that one stretch of coastline, eating shellfish to survive an ice age that had made the rest of the continent unlivable. Every single person alive today, every city, every language, every argument happening in a comment section right now, traces back through that one narrow point, on that one stretch of rock. Modern humans, anatomically much like us, had already appeared in Africa by around 300,000 years ago. What almost finished the species off came later, during a brutal glacial period scientists refer to as marine isotope stage 6, or MIS6, which gripped the planet from roughly 195,000 to 123,000 years ago. Marine isotope stages are how researchers label distinct stretches of Earth's climate history. Each one is identified from oxygen isotope ratios preserved in deep-sea sediment cores, essentially chemical fingerprints left behind by how much of the planet's water was locked up in ice at any given time. MIS6 was one of the coldest and driest such stages on record. Across Africa, the interior dried out dramatically. Grasslands that had supported large mammal populations, and the humans who depended on them, collapsed into desert and semi-desert. Rivers that had run for tens of thousands of years slowed or vanished entirely. Populations that had spread across the continent during better times had nowhere left to retreat to, except toward the edges. The mechanism behind this particular cold snap traces back to changes in the northern hemisphere's ice sheets, which grew large enough during MIS6 to alter global wind and rainfall patterns far beyond where the ice itself sat. Africa, despite being nowhere near the ice sheets directly, felt the consequences through shifted monsoon systems that simply stopped delivering the rainfall the continent's interior had relied on. This played out as a sustained, generational drought layered on top of colder temperatures, lasting long enough that entire regional ecosystems had time to collapse and fail to recover before the climate improved again. Archaeologist Curtis Moran of Arizona State University has spent nearly 2 decades excavating Pinnacle Point and estimates that the entire surviving population of Homo sapiens during the worst of this period may have numbered only a few hundred breeding individuals. Moran's team began serious excavation there in the early 2000s. What makes the site so valuable is its sheer continuity, undisturbed layers stacking up year after year, letting researchers watch this population's habits shift in fine detail as conditions around them changed. For context, a population of a few hundred is smaller than attends a single university lecture hall. Every person alive today, all 8 billion of us, may trace back to a group that would not have filled a modern high school. Archaeology alone would be a shaky basis for a claim this dramatic. It happens to line up with a separate line of evidence that has nothing to do with digging in the ground at all. Long before anyone ever excavated Pinnacle Point, geneticists studying modern human DNA had already noticed that our species carries unusually low genetic diversity for how large and widespread we are. That pattern is normally explained by a population bottleneck, a period where the number of people contributing offspring to future generations shrank dramatically, narrowing the genetic starting point for everyone who came after. Researchers have identified at least 2 major bottlenecks in the human genetic record. One occurred later, sometime between roughly 70,000 and 50,000 years ago, tied to the migration of a small group of people out of Africa into the rest of the world. The other, older and considerably more severe, is estimated to fall somewhere in the range of 200,000 to 145,000 years ago, depending on which genetic method and which set of assumptions a given study uses. That earlier window lines up almost exactly with MIS6, One widely cited estimate from geneticist Nelson Fagundes and colleagues put the effective population size during this earlier bottleneck at somewhere in the range of a few hundred individuals. Effective population size is not simply a head count of everyone alive at a given moment. It measures how many individuals were actually contributing offspring to future generations, which tends to be a smaller, more meaningful number than the raw population count, since it strips out anyone who never reproduced. Fagundes's figure matches Moran's independent estimate from the Archaeology of Pinnacle Point remarkably closely, given that the two approaches have nothing methodologically in common. One comes from counting layers of shellfish and stone tools in a cave. The other comes from mathematical models run on the DNA of living people. Two completely different kinds of evidence, converging on the same rough number for the same rough window of time, falls short of proof, but it is hard to wave away as coincidence. It is worth being upfront that genetic dating methods like this one come with real uncertainty attached. Different studies, using different assumptions about mutation rates and generation length, have produced estimates for this same bottleneck ranging anywhere from roughly 200,000 years ago on the older end to under 150,000 years ago on the more recent end. That is a wide enough spread that no single number should be treated as final. What has stayed consistent across most of these studies, regardless of the exact date each one lands on, is the rough scale of the crash itself, a population reduced to somewhere in the hundreds, not the thousands, at its lowest point. As the African interior grew unlivable, survival meant finding refuge somewhere the drought had not reached. That place was the southern coast, specifically a stretch of shoreline near what is now Mossel Bay, South Africa. A series of caves overlooking the sea there, most famously one researchers call Pinnacle Point 13B, or PP-13B, preserve a record of human occupation stretching from roughly 164,000 years ago down to about 35,000 years ago, a span covering both the worst of the MIS-6 crisis and the population's eventual recovery. What made this coastline different was simple. It offered a food source that did not depend on rainfall. During glacial periods, global sea levels dropped by over 100 meters as more of the planet's water froze into ice sheets, and that drop exposed a wide, gently sloping shelf off the South African coast called the Agulhas Bank. What had been shallow seafloor became dry, grassy plain, likely home to large grazing animals moving through it. Meanwhile, the coastline itself, now pushed further out to meet the newly exposed plain, remained lined with mussels, abalone, and other shellfish. A food supply that keeps producing regardless of drought, refilling itself on a tidal clock that no famine could interrupt. The region behind the cave mattered just as much as the sea in front of it. This part of South Africa sits inside what botanists call the Cape Floral region, one of the richest concentrations of plant diversity on the planet, and it happens to be unusually dense in geophytes, plants that store their energy underground in bulbs, corms, and tubers. Unlike fruit or leafy greens, geophytes stay edible and available, even through drought and cold, buried safely below whatever is happening on the surface. Between the shellfish beds at low tide and the geophytes in the ground behind the cave, this stretch of coast offered reliable food regardless of the weather, something almost nowhere else on the continent could claim at the time. The exposed Agulhas Plain itself may have added a third food source on top of the other two. Researchers studying the region have proposed that the newly exposed grassland likely supported migratory herds of large grazing animals moving across it in seasonal patterns, similar to the migrations still visible on the African plains today. Though direct evidence for hunting these specific herds during this exact window is harder to pin down than the shellfish and plant evidence. A hunting group operating from a fixed cave, rather than following herds on foot across open country, would have needed to know exactly when and where those migrations passed close enough to intercept, which is its own kind of accumulated environmental knowledge, distinct from the tidal timing the shellfish beds demanded. Taken together, the possibility of shellfish, geophytes, and seasonal game in roughly the same stretch of coastline would have made this one of the most reliable food environments left standing anywhere on the continent during MIS-6. It is hard to overstate how much of a lifeline that represents. Elsewhere on the continent, food was scarce and getting scarcer by the year. At Pinnacle Point, the tide came in and went back out on schedule, drought or no drought, and it brought dinner with it every time. Low tide only lasts a few hours at a stretch, though, which means shellfish gathering was not something one or two people could handle alone. It favored coordinated groups working the exposed rocks together before the water returned, which by itself is a small window on how these people were organizing their days around something more structured than opportunistic foraging. Pinnacle Point earns its place at the center of this story because of how rare its kind of evidence actually is. Researchers studying this exact period have pointed out that directly dated Middle Stone Age sites from the MIS-6 window are strikingly rare anywhere along the southern African coast. PP13b is, by some assessments, the only site in the region with solid direct dating covering this specific stretch of time. Other coastal sites nearby, including Clayseas River further east, preserve related evidence from slightly different windows, but none match Pinnacle Point's continuous, tightly dated record spanning the actual worst years of the crisis. Part of why the record is this thin has nothing to do with how many people were actually alive at the time, and everything to do with how fragile evidence this old tends to be. Coastal cave sites are rare to begin with. A cave has to be sheltered, elevated above storm surge, and close enough to the shoreline to be useful, and finding all three conditions in one place is not common along any coastline. On top of that, rising and falling sea levels over the following 100,000 years have destroyed or buried an unknown number of sites that might once have told a similar story. Pinnacle Point survived largely because of where it sits, elevated enough on the cliff face to avoid being washed away by the very ocean that made it valuable in the first place. Everywhere else along that coastline, the record simply is not there, whether because people were not living there, or because the evidence has not survived, or has not been found yet. What that one cave actually preserves, though, goes well past shellfish shells and stone flakes. Here is the part of the story that shifts it from pure survival horror into something more interesting. The people sheltering at Pinnacle Point were doing more than scraping by. The archaeological layers there, including some of the very oldest ones, show signs of behavior that looks symbolically human, not simply survival-driven. Excavators have recovered pieces of red ochre, a naturally occurring pigment, worked and used in ways consistent with body decoration or symbolic marking, rather than any practical function. Alongside the ochre, researchers have found fragments bearing deliberate engraved patterns, the kind of markings that imply abstract thought rather than accident. The stone tools tell an even stranger story. Archaeologists working at Pinnacle Point struggled for years to replicate the glossy, reddish blades they kept pulling out of the ground, made from a local rock called silcrete. It turned out these early humans were deliberately heat-treating the stone before working it, burying raw silcrete under a fire and keeping that fire burning for around 30 hours, using somewhere between 20 and 40 kilograms of hardwood to chemically transform the rock into something that flaked into sharper, more controllable blades. Researchers have dated this practice at Pinnacle Point to as early as 164,000 years ago, which would make it the oldest known example of humans using fire to engineer the properties of a raw material rather than simply cooking with it, though a handful of researchers have challenged that specific early date. What is not seriously disputed is that heat treatment shows up reliably in the toolkit here by around 72,000 years ago. Either way, this is further evidence of sophisticated planning. A 30-hour firing process only works if someone plans it, tends it, and repeats it enough times to know it works. Then there is the act of gathering the shellfish, which sounds simple until you consider what it actually requires. Exploiting a tidal shellfish bed reliably, rather than opportunistically, means understanding tidal cycles, lunar patterns, and seasonal shifts in productivity well enough to return to the right patch of coastline at the right time, over and over, for generations. That takes accumulated, transmitted knowledge, the kind that has to be taught rather than rediscovered by every new person who tries it. Researchers studying this evidence have specifically pushed back against an older assumption in the field, that cognitively modern behavior, meaning symbolic thought, abstract reasoning, and complex planning, evolved long after anatomically modern humans first showed up. At Pinnacle Point, the two seem to arrive together, in a population that was, by every population estimate available, on the edge of vanishing entirely. Symbolic marking specifically carries weight beyond simple decoration. Anthropologists studying similar evidence elsewhere argue that shared symbols, such as a particular ochre pattern or a specific way of marking the body, function as a kind of identification system, a way for a small, scattered population to recognize its own members and maintain group cohesion under pressure. For a population numbering in the low hundreds, spread thin along a single stretch of coastline, and dependent on cooperation to exploit shared food sources, like tidal shellfish beds, that kind of social glue was plausibly part of what kept the group functioning as a group at all, rather than fragmenting into smaller units, too small to survive on their own. Pinnacle Point is not an isolated case either. Roughly 100 kilometers along the same coastline sits Blombo's Cave, where a separate research team has recovered engraved ochre pieces and deliberately perforated shell beads, dating to between about 100,000 and 70,000 years ago, evidence from a later stretch of the same broader coastal tradition. Seen together, the two sites paint a consistent picture: a durable regional culture, built around the same coastline, the same food sources, and the same underlying behaviors, sustained across tens of thousands of years, rather than one unusual group doing something no one else managed. Myth 6 eventually loosened its grip around 123,000 years ago. As the climate warmed and rainfall gradually returned to the African interior, the grasslands and river systems that had collapsed during the crisis began to recover. And so did the population that had spent tens of thousands of years surviving on a narrow strip of coastline. Occupation at Pinnacle Point does not stop the moment the climate improves. The archaeological record there continues for well over 100,000 years after MIS 6 ends, all the way down to roughly 35,000 years ago, showing a population that kept using this coastline as a reliable base even after the original emergency had passed. That continuity matters. It suggests the survival strategy developed here, exploiting shellfish, geophytes, and heat-treated stone tools, did not simply get abandoned the moment conditions eased. It became a durable, transmitted way of life, one generation teaching the next, refined rather than discarded once the emergency passed. From that recovery, the population did what small, growing populations do. It expanded outward. Descendants of this group, or populations closely related to them, spread back across the African interior as it became livable again, and in the tens of thousands of years that followed, further descendants pushed out of Africa entirely, eventually reaching every inhabited continent on Earth. None of that later expansion required the coastal strategy itself to travel with them. Once the climate stopped forcing the issue, descendants of this population went on to build entirely different survival toolkits suited to deserts, forests, and eventually Ice Age Europe. The coastal strategy was the right specific answer to a specific crisis, at a specific place and time, and it did its job before quietly stepping aside once it was no longer needed. There is a strange postscript to this story. Around 74,000 years ago, the Toba supervolcano in Indonesia erupted, one of the largest eruptions of the last 2 million years. Toba is often credited with nearly wiping out humanity in its own right, a separate and more popularized claim, and one that current genetic evidence does not actually support. What that popular version of the story never gets into is what happened at Pinnacle Point specifically when the ash actually arrived. In 2018, a research team led by Moran identified microscopic volcanic glass fragments, called cryptotephra, preserved directly within the occupation layers at PP13b. Cryptotephra shards are essentially invisible to the naked eye, small enough that they settle into sediment without leaving any obvious ash layer a person could spot by walking through it, and they can only be identified by taking sediment samples back to a lab and examining them under magnification. Once found, each shard can be chemically fingerprinted, since every volcanic eruption produces glass with a distinct chemical signature based on the specific magma that produced it. The fragments recovered at Pinnacle Point matched Toba's signature precisely, confirming that ash from the eruption genuinely reached this specific cave, on the opposite side of the Indian Ocean from Indonesia, roughly 74,000 years ago. If this population had been seriously disrupted by the eruption, that disruption should show up as a gap or a shift in the archaeological layers surrounding the ash. It does not. Occupation continues before, during, and after, without any visible interruption in tool types, hearth use, or the general rhythm of how the cave was being used. The team's own interpretation is straightforward. This specific population, already adapted to a reliable coastal food source, simply kept living through one of the most violent volcanic events in recent geological history. Whatever climatic disruption Toba caused elsewhere in the world was likely far less severe than popular accounts suggest. At Pinnacle Point specifically, it does not appear to have meaningfully touched the one food strategy this population had already spent well over 100,000 years perfecting. The population that had already survived an ice age severe enough to reduce it to a few hundred people went on to shrug off a supervolcano roughly 100,000 years later, using the same shoreline and the same shellfish beds. It just worked twice. None of this looked dramatic while it was happening. No single battle, no single night that decided everything. Just an ice age that dragged on for tens of thousands of years, and a handful of people working a shoreline for shellfish because the alternative was starving somewhere inland. Then later, a volcano's ash settling over a cave that had already seen worse. Every person alive today descends from that. A small group, backed into one stretch of coastline, figured out how to secure food when almost nowhere else on the continent could say the same, and held on long enough to become all of us. The cave is real. The number is real. 8 billion people live on this planet now. It is easy to forget how close that number once came to being the last one.